the problem. And now we're ready to immortalize this. Yes, sir.
It was I can actually pull up the problem, but it was the question on, there was the thin line of charge, to the Y max from 0 to Y max, and then from X, it was a point X 0, 0, so it was on the X-axis, and it was finding the X component of dE, the Y component, and the electric field.
This is the second problem?
Yeah, and
Okay.
I struggled to do that, like I did something, and then on problem 3, it really showed that I didn't get the right formula. And I
Yeah, if
really
you-
didn't know how to go about it. I tried doing it similar to what we did in class one time. But that was, instead of having the uniform charge, perpendicular to the, point charge, it was on the same
Alright, so let's
axis.
take a gander at this one. Alright, so I have an older version of it. I'm assuming it has not changed drastically since then. So positive point charge Q located at X naught 0. So let's set up our axes here. X naught 0. And I have some charge Q. Oh, I guess I labeled this little q. I have a thin line of uniform charge of positive capital Q extending from 0 to Y max. So basically, is this the problem so far? So it's Y sub naught, I guess 0 Y sub naught. And the charge here is big Q. Element of length dy is located at 0 y, so and it would have a charge of dq. The x component. All right, so I know that there's an electric field at this point right here, that from that differential in that direction. Now, we don't know whether Q is positive or not, but we assume it's positive, and then if later on it's a negative sign, well, you just put the negative number in there, and the vectors will flip accordingly. I know that the electric field is KQ, the magnitude, KQ over R squared. And I have some angle theta here, some angle theta there, so I can break my electric field up into its components. dE is equal to K dQ over R squared I hat J hat times that's the horizontal piece, so cosine of theta I hat minus K dQ over R squared sine theta J hat. So this is basically a generic thing. We have the magnitude right here, and then the cosine and sine just to get the components. All right, so far so good? Yeah. I say to put the answer in terms of Q, Y max, X naught, and Y. All right, so I need to figure out the relationship of dQ to Y. Do the element dq. Well, you actually could get away with, oh, I don't have theta in there. You can leave dq in here, but you'll have to deal with it at some point. Given my right triangle right here, I know that this distance here is y, and we can, of course, the typical stunning visual effects. I know that distance is y, This distance here is x sub 0, and that's r. So r squared is just y squared plus x sub naught squared. That's an equal sign there. And I know that cosine theta, since theta is not part of the problem, I have to put it in there as an intermediate step. Eventually it has to go away. I know it is the adjacent over the hypotenuse, so that is x sub 0 over r. So just dealing with this piece to start with, we have k dq over r squared cosine of theta, x sub naught over r. So I got r cubed on the bottom. So k x sub naught over r cubed of dq. And then, since r is not to be in the final answer, we have our connection of r with x sub naught and y right there. So this becomes k x sub 0 over y squared plus x sub naught squared to the 3 halves dq. As I said, so we have k is a constant, x sub naught, y, dq, y max. Were those the variables that I could use in the answer?
I think,
I know y max is one of them.
Q, Y max, X sub 0, Y, and then dy.
Okay, I don't have d, okay. Earlier version had q allowed. All right, so you can't stop here then. All right, so we need some relationship between dq and dy. Well, I assume it's a linear, it's a uniform charge density. So uniform charge density is lambda, and that's going to be dq dy. So it's just charge over distance, over length. And since we're looking at this infinitesimally small bit of y, that has an infinitesimally small bit of dq. So dq is equal to lambda dy. So that substitution is going to go in. And the last bit is that lambda was not one of the choices there, because again, I didn't give lambda as a value in there. So, but we know something about it. We know it's uniformly distributed here. So lambda should also be equal to not only this differential, but also the total charge divided by that total length, which is y sub 0. And so we are left with the horizontal component so I got k x sub 0 over y squared plus x sub 0 squared, that whole thing to the 3 halves, times dq, and dq is lambda dy, and lambda is big Q over y max dy. So that's dq, okay, something like that.
And the total electric field formula would just be that combined with the J hat?
Yeah, you integrate.
Okay.
Yeah, so k, x sub naught, big Q, y sub max are all constants. So it's a, if you want to do it the long way, trig substitution.
So is that DEX equals that? Or is
Oh, yes, you are correct. It is DEX. Does that answer your question?
Yeah,
perhaps did more than I should have, but
yeah, I just had problems with the cosine and sine. I didn't really know how to go about that. I didn't really think about putting an angle in there, so that was the main issue.
okay.
And in the problem, it's negative Q, so I could just make those negative, I guess.
And if it's a negative cube, then
It's just a different,
yeah, so as in the next problem?
no, for the master set, it's negative Q.
Yeah, no, for the master set, because number 2 was coming up with a formula.
Yeah,
Problem.
he was using negative Q, for the line of charge.
Yeah, so if Q is a negative number, then just plug in the negative number for Q. And the vector will change accordingly.
Okay, yeah, that answers it. And I could do 3 from that.
Yeah. I do want to point out that for problem 4, at least in the old version, I assume it's still problem 4, where you've got a line of charge here. So line of charge, and you got a point here. What you derived in the first one was you got the charge here, and you're looking at a point in this spot. Now I've got it along the full range here. So you can do half of it, just do 0 to 4 and then double it, recognizing that the components, the vertical components will cancel out. So you only have to do the I part. Or if it's like this, going from -3, is that another one I did? At least not in that version. But it seems like there was another one where it goes from -3 to 8 or something like that. Just be careful of your integration. That reality, if you're using what you derived in problem 2, it's 2 problems from 0 to 8 and then 0 to -3.
But for the
Or
symmetrical
-3
one-
to 0, sorry.
For the symmetrical one, there's like a special case, like equation, right, or formula.
There might be. Well, I know that for the symmetrical one, that the way this is set up, the vertical components cancel out, so you only have to do the X version of it. There might be a special case for it, but I try not to remember the special cases. Seeing if there were a special case here. Electric field at a point on a perpendicular bisector, yeah, so they do give a special case here.
Would you include that formula on test, or would you expect us to derive this?
I don't think I give that one. The quizzes were in my hand. There we go. No, that's not it. I win, I pick them up. I then. So here. The reason why I'm scrambling, one, it's the quiz you're gonna take, but also, the formulas at the top of the quiz page should be the formulas, there we go. And is it on there? Oh, it is on there. I did give it, you just have to know which one it is. Because I don't give any context, I just give the formula. All right, I think we've done enough song and tap dance. Any questions about the Flash? Have any of you actually seen the Flash Gordon movie? Came out in the 80s, soundtrack by Queen. Okay. Ask your parents about that too when you ask them about Mr. T.